This is our Algebra 2 section 10.2 on parabolas. And before we get into parabolas, we'll do a little bit of algebra work first, just to make sure that we have the basic skills background in order to do a lot of the parabola stuff. And we're looking at completing the square. So I have this equation, and I want to solve it, and I'm going to solve it by completing the square. First off, I'm going to move the 3 over to the other side, so now it's x squared plus 8x is equal to 2 when we subtract 3 from both sides. Then I'm going to put a little line right here, and then that same line on the other side. And I have to figure out what number goes on here in order to complete this square. Now the process is to make sure that the leading coefficient on the x squared is 1, and that's taken care of. And then we look at the coefficient on the x. We're always going to take half of that number, half of 8 is 4, and then we're going to square that number. 4 squared is 16, and we're going to add 16 then to both sides. Now to look at these 3 terms over here on the left, I'm looking to factor them. What 2 numbers multiply to 16 and add to 8? And it's no coincidence that that number is 4 and 4. 4 times 4 is 16, 4 plus 4 is 8. It is the half number that we wrote over here, so it factors as x plus 4 squared. On the right, we're going to add the 2 plus the 16 to now make that 18. The goal is to get x by itself, so now if we took the square root of both sides, we would have that x plus 4 is equal to plus or minus the square root of 18. Last step to get x by itself is to subtract 4 from both sides, and if we do that, we get x equals negative 4 plus or minus the square root of 18, and if we break down the square root of 18, it comes out to 3 root 2, and there is our solution for x. We would have gotten that same answer if we had subtracted 5 from both sides to make it equal to 0, and then use the quadratic formula. But this is just another way about going about that type of problem. Here's our next one. The process is going to be exactly the same. Half of negative 10 is negative 5. When we square that, that means we're adding 25 to both sides of the equation. Factor the left side, that's x minus 5 times x minus 5. It multiplies to this, it adds to that. Once again, it's that half number. The right side, those numbers are added together. Take the square root of both sides, so x minus 5 equals plus or minus the square root of 27. And then lastly, add 5 to both sides. X equals 5 plus or minus the square root of 27, which breaks down to 3 root 3. This next problem gets to be a little bit harder because when we apply that same process, we have to deal with fractions. And that's because this number is odd. Half of 3 is 1.5 or 1.5 or 3 over 2. And we're going to use the improper fraction of 3 over 2. So half of 3 is 3 halves. And we've always squared this number. Square the numerator, square the denominator. And that is 9/4. That then gets added to both sides of the equation. Next step is to factor. What 2 numbers multiply to this and add to that? Kind of a hard thing to do because of the fraction in here. But if we use that process we've used before, this number 3 halves is the key. It's going to be x plus 3 halves squared. Then on the right, if we add those together, that comes out to 13 over 4, common denominator and so forth. Next, take the square root of both sides. So x plus 3 halves equals plus or minus the square root of 13 over 4. One more step, we need to subtract 3 halves from both sides. So negative 3 halves plus or minus. And then breaking this one down, the square root of 13 we don't know, but for the denominator, the square root of 4 is 2, so we can actually take that square root to simplify it, and there is our solution for x in this one. Moving over to the right, the first thing I notice here is that the leading coefficient is 1/3, and I don't like that. I want that to be a 1x squared, so we're going to take everything on both sides and multiply by 3. That would then give us x squared plus 6x equals 12. Now the problem is looking a little more familiar. Half of 6 is 3. 3 squared is 9, so we're going to add 9 to both sides of the equation. The left side factors then as x plus 3 squared. Add those numbers together on the right, we have 21. Take the square root of both sides, so x plus 3 is plus or minus the square root of 21. And then the last step is to subtract 3 from both sides, so negative 3 plus or minus the square root of 21. That doesn't break down this time, so we get that answer. So getting to the idea of a parabola, we'll use those skills for completing the square as we get more involved with the parabola. But let's define what a parabola is. This is the set of all points that are the same distance between a given point and a given line. So if I'm on a graph, and let's say here's our given point, and here is our given line. We want to know what are all the points that are the same distance between them. So I could go right in between them right here to get that red point. And then the distance is the shortest distance, so I'm trying to find another point that the distance to this line is the same distance to that point. And eventually it's going to start curving up, and I can get those same kind of points going on over to the left. Eventually, when we get all those points, the shape is going to look something kind of like this. This is our parabola. Key things here. This line is called the directrix. This point is called the focus. And then this point, the one that goes directly between the focus and the directrix, is called our vertex. So again, the definition of a parabola is that it's the set of all points, all these red points, that are the same distance between a given point, the focus, and a line, the directrix. Nice chart that details all the important terms, what the equation would look like, what direction it's going to open, what we know about the vertex, the axis of symmetry. The focus equation and the directrix equation are a little bit hard to understand, so we're going to look at them in a slightly different way. But in this first column, if it is a y with an x squared, so x is the only variable that's squared, that means that the graph is either going to be opening up or it's going to be opening down, depending on if the number in front of the x squared is either positive or negative. So the parabola could go up or down depending on the a value. For the column on the right, we have x equals y squared, and when y is squared, it's either going to open up to the right or it could open up to the left, depending on where the focus and the directrix are at. Graphs can move in a lot of different directions, but they're either going to open to the right or open to the left if it is a y squared value. We have focus, directrix, axis of symmetry, and vertex. We talked about all these. The only one I didn't mention before was the axis of symmetry. So if we have a parabola like this one, the symmetry means that it has the same thing on both sides of our axis. So if I figure out where the vertex is at, then on the left side and the right side of that, we could just fold across that line and we'd have the same thing. Here would be an example of an axis of symmetry for the start of this parabola. We'll look at two different forms, or two different ways we can write a parabola. First is the standard form. That's y equals a times x minus h squared plus k. And from this form, if a is positive and the x value is one that's being squared, I know that the parabola would be opening up. If a was a negative value, I know the parabola would be opening down. The other thing I know directly from this form is that the vertex would be h comma k. So when it says x minus h, the h value, or the value of h is the x value of our vertex, and k is the y value of our vertex. The other form we have is what's called general form. That's y equals ax squared plus bx plus c. Now in this form, it doesn't give us as much that we can take directly out of it, so we're going to use the process of completing the square to get it back into a standard form, because that is going to be the more useful form for us. So here's our first example of a parabola, and right now it's not in the form that we prefer, so we're going to do a little bit of algebra with it to get it into a better form. And once we have it into that standard form, we are then going to find the vertex, the axis of symmetry, and tell whether the graph is opening up or down. Step 1, y equals x squared minus 12x space plus 7 space. Now, I need to complete the square. Half of negative 12 is negative 6, and when that number is squared, we get 36. So what we're going to do on this line is add 36, and normally we would add 36 to the other side. But I want this y to be by itself, so if I added 36 over here, I'd end up having to subtract it back over to this other side, so we're going to subtract 36 there. Another way of looking at this is, if you add one number and subtract that same number from the same side, you really add at 0, so nothing really changed. So we add 36, subtract 36, both to the same side, and that's okay. So a little bit of manipulation there to make this better for us. And as I look at these first three terms, that will factor as x minus 6 squared. Think back to that lesson on completing the square from the beginning. Now we have this 7 that was from the original problem, minus 36. That minus 36 was subtracted to counterbalance that other number. When we subtract those, that's going to be a negative 29. And now we have it in a good form. From here, I can answer the questions. First of all, the vertex would be 6 comma negative 29. And it is an x squared, which means it's going to be going either up or down. The coefficient in front of this is just a 1, so it's positive, which means this graph is opening up. And for the last question, the axis of symmetry. So if I make a quick sketch, over 6, down 29, here's the vertex. It's opening up. I know that because the number in front of this is positive. Then the axis of symmetry would be splitting it like this, equally in half. It's a vertical line, so that means that it's x equals, and it's going right through the x value of the vertex. So it's no coincidence that the x value of our vertex and the x value of our axis of symmetry are going to be exactly the same. So here's our vertex, our axis of symmetry, and it is opening up. This one with the same type of equation. Notice there's a 2 in front of the x squared this time, and I really don't want to divide everything by 2 and move and have this divided by 2 because I want this to be a 1y, and we've got that accomplished. So here's the process in this problem. We're looking at the x squared. I'm going to factor a 2 out of it. Factor a 2 out of the 6x. Leave a blank, and then we'll leave that 20 out there at the end and put another blank to counterbalance. Inside of the parentheses, I'm going to take half of this number, and half of 3 is 3/2. That number then gets squared. Square the numerator, square the denominator. That's 9/4. But really what happened is we didn't just add 9/4 to the side. Remember that 2 we factored out earlier? These 3 terms on the inside are really 2x squared, 6x, and this is really 2 times 9/4, which would make it 18/4. 18/4 simplifies to 9/2. So this red number really represents a positive 9/2. So then we're going to subtract 9/2 to keep it all consistent. Next step, we'll keep this 2 factored on the outside. On the inside, we have an odd number. We have a fraction, which makes it uglier, but remember that little process. This half number is the key. It's x plus 3/2 squared. At the end, we have some work with fractions. If we add those together, this is 40/2 minus 9/2. That's 31/2. And I can look at this and start answering the questions. First of all, vertex is -3/2, comma 31/2. And it is an x equation. The coefficient in front of this is positive, so I know it's going to open up. Vertex of -3/2, comma 31/2 is right here. It's opening up. The axis of symmetry is this line, splitting it in half. Once again, it's a vertical line. It's going to be x equals -3/2. It has the same x value, once again, as the x value of our vertex. The last example of that same type. Big difference is this is x equals y squared instead of y equals x squared. So that makes it a little bit different. A lot of the process is the same though. We're going to split it up a little bit. Half of 2 is 1. 1 squared is 1, so we add 1 and subtract 1. We didn't have to factor out any GCF this time, so I'm not worried. It's not like the last one where I had a 2 on the outside and had to subtract a number that looked to be different. Factoring this, it's going to be y plus 1 squared plus 2 when we combine those two numbers together. So then the vertex is going to be +2, comma -1. Normally it's the opposite of this value for x, but since the y is what's being squared in there, we're taking the opposite of that and it goes in the y value. This number is tagged along at the end, so it's going to be that number for the x. So the vertex is 2, comma -1 over 2 down 1. The coefficient in front of all this is positive, but since it's a y squared, it's not opening up. It's going to open to the side. So I'm not saying open up or down this time. We're going to say opens to the right. And then the axis of symmetry is going right through that vertex. Now it's a horizontal line. So the equation of this axis of symmetry is y equals. And the y value of this axis of symmetry is the same as the y value of the vertex, which happens to be -1. So the equation of our axis of symmetry is y equals -1. So vertex, axis of symmetry, and it opens to the right.